and Crash Course Instrumentation, Understanding Matter, Atomic Structure, Energy, and Work. Introduction. Welcome to Crash Course Instrumentation. In this episode, we're breaking down fundamental concepts crucial for understanding instrumentation: matter, atomic structures, energy, and the meaning of work and power. Let's dive right into these core ideas and make them easy to understand. What exactly is matter? Matter is everywhere. It's anything that has mass and takes up space. Everything around you, from the chair you're sitting on to the air you're breathing, is matter. But what's matter actually made of? All matter is composed of tiny particles called atoms. Imagine an atom as a miniature solar system, with a nucleus at the center made of protons and neutrons, and electrons orbiting around it. Protons carry a positive charge, neutrons are neutral, and electrons carry a negative charge. Atoms and molecules. Atoms can bond together, forming molecules, which are the building blocks of the substances around us. Take water, for example. Each molecule of water is composed of 2 hydrogen atoms and 1 oxygen atom, chemically bonded together, H2O. These molecular interactions are the essence of chemistry and are fundamental to understanding instrumentation and electronics. Electronic structure. Why electrons matter. Electrons don't just orbit randomly, they follow structured paths or energy levels. Think of these energy levels as seating rows in a theater. The electrons fill the lower rows closest to the nucleus first, which are lower energy states, and then occupy higher, less stable levels. Why is this important? Because how electrons fill these shells determines how atoms interact with each other, impacting how they form chemical bonds and conduct electricity. Understanding electron configuration is key to grasping electronics and instrumentation systems. Energy, potential versus kinetic. Energy is essentially the capability to make things move or change. There are 2 primary forms of energy we need to understand. Potential energy is stored energy waiting to be used. Imagine stretching a rubber band. The energy you put into stretching it is stored as potential energy. Kinetic energy is energy in motion. When you release that rubber band, the stored energy converts to kinetic energy as the band moves. Energy continuously converts between these forms but is never lost, only transferred. This is the law of conservation of energy, a fundamental principle in all physics and engineering. Work and power explained simply. In physics, work is defined specifically as force applied over a distance. When you push a box across the floor, you're doing work because you're applying a force, push, and the box moves, distance. Power, on the other hand, is how quickly you do this work. For example, lifting a weight slowly versus quickly. The faster you lift, the greater your power output. This is crucial in instrumentation when measuring and optimizing performance and efficiency. Putting it all together. So why do these concepts matter in instrumentation? Well, instrumentation is about measuring, monitoring, and controlling physical phenomena. Understanding how atoms interact, how energy moves, and how to quantify work and power helps instrumentation professionals design effective systems, whether it's for controlling industrial processes, ensuring safety, or improving efficiency. Summary and key takeaways. Let's quickly recap. All matter consists of atoms made of protons, neutrons, and electrons. Electron arrangement dictates chemical behavior and electronic interactions. Energy exists as potential or kinetic, constantly converting but never disappearing. Work involves force moving an object. Power measures how fast this work is done. Conclusion and call to action. If you found this video helpful, please like, subscribe, and hit the bell icon for more insightful content from Crash Course Instrumentation. Stay tuned as we continue exploring instrumentation basics and beyond, making complex ideas simple and clear. See you in the next episode!